Hello everyone, Mr. Hissner here, and today we're going to be looking at the kind of the next step in our transversal journey as we transverse transverses, right? So today we're going to be looking at what happens when the lines are parallel. What happens when the lines never touch and are cut by a transversal. So today we're going to take a closer look at that property, that situation, that conundrum. So as a reminder, we have vocab. So now the vocab you should know. You're going to be responsible for knowing these things. If you don't know it, make some flashcards, quiz yourself, know it. Because from here on out, we're going to be using these terms basically for the rest of the year, or at least for the next two marking periods. Most of the sections we cover deal with what we just learned. So it will behoove you not to learn it. So vocab we should know, and now we are here, right? We are at the number phase of our journey. And so here we have just a couple more ideas. So this is what happens when the lines are parallel, these things are true. When the lines are parallel, these things are true. So what we have is when the lines are parallel, corresponding angles are congruent, right? So that means that they're the same figure and their measures are equal. Alternating interior angles are congruent. That means that they're the same figure and that their measures are equal. Alternating exterior angles are congruent. Consecutive interior angles are supplementary. These are supplementary. So these mean that they have a sum of 180 degrees. That's what supplementary means. And of course, we know this is that vertical angles are always congruent. Remember that. And also that linear pairs are always supplementary. And again, that is that sum of 180. And I'm going to be using these two properties to get to this other stuff. I'm going to be using those two properties, the idea of a vertical angle and a linear pair, to get me through to the next step in this phase. Okay, so let's write this down, take some notes, right? Have this in your pocket that you can pull out and unfold for later. And we are going to look at the first example. Now, you'll notice that I have all of this mess over here. We have all this mess over here, but watch what I'm going to do. What I'm going to do is, if I was you, what I'm going to do is I'm going to take this figure and give it a draw. How long did that take me? 4.5 seconds. And then what I'm going to do is I'm going to look at what I'm given. I'm given angle 1. So now I'm just going to work on my figure here. Notice that these lines are parallel. That's what this means. That's what these two mean. These are parallel lines, right? So that's what those little arrowheads mean, that these two lines are parallel. And so we are told that angle 1 here is 65 degrees. Now watch this. Watch this. Vertical angles are congruent, right? Correct? Correctamundo. Yes, vertical angles are congruent. And 1 and 3 are vertical angles. So this angle is 65 degrees. Now, I'm looking for an alternating interior angle, right? Because this is my transversal region. Blue is the outside, the bread of the sandwich. Green is the inside. And so I'm looking at angle 3. And watch this. If I look at angle 3 and angle 5, these are alternating interior angles. So that is also 65 degrees. And oh, 5 and 7. Clearly 5 and 7 are vertical angles. And so 7 is 65 degrees. So what I did here was is I noticed, hey, vertical angles, alternating interior, vertical angles, right? Okay, so watch this. Vertical angles, wait a second, that's a linear pair. 7 and 8 are a linear pair. They add up to 180 degrees. So I know that 8 will be 180 minus 65, which is 115. So this is 115, and look, the cycle continues. These are 8 and 6 are vertical angles, and so they are congruent. So 6 is 115. 4 and 6 are alternating interior angles, and so they are the same. So 4 is 115, and then we use another vertical angle here. So that's 115. And so what I'm going to do here is off to the side, I'm going to fill in these values and the angle relation I used. So I found 115, and this was from a vertical angle. Number 3 I found to be 65, and that again was from a vertical angle. Number 4 we found 115, and this was from alternating interior angles. 5 was also from an alternating interior angles. 6 we found from a vertical angle because we went from 6 to 8, so this is 115. This was a vertical angle. 7 was a vertical angle as well. And then 8, finally, this is 115, and we found this using a linear pair, the property of a linear pair, because this was supplementary. So that's what I would do. For a problem like this, what am I going to do? I'm going to look at angle number 6, and I'm going to say, okay, this is 142, and vertical angles, alternating interior, vertical angles, linear pair. So this one is going to be 180 minus 142, which is 38. So this is 38, alternating interior, or vertical angles, alternating interior, vertical angles. So right away, line them up, knock them down. This is the pattern for this. This is how I do this. It just is satisfying to just kind of go zigzag and then go zigzag. So thanks for watching, guys.